All right, today we're going to talk about the sampling method. This is from section 1.2 from our book. Last time we talked about population versus sample and why we need a sample. So let's say I'm interested in like what percent of people in LA have COVID-19 virus. Interesting question and very important question. But again, there are so many people in LA, which is our population. So it's kind of impossible to know. So what we do usually is we take a sample and study our sample, and from there see what we can say about the actual population, which is everyone in LA. So today we'll talk about different ways we can sample people. Generally speaking, we want our sample to be fair and well representative of the population. So we'll talk about different ways we can do that today. I'm going to talk about number 5 first. It says, finish the sentence. A random sample is a sample in which every individual has equal chance of being selected. In order for our sample to be fair, we want to make sure that everyone has equal chance of being selected, which means that I don't want one particular group or person to be more likely to be selected as our sample than others, right? So in order to be fair, I want to make sure that everyone has equal chance of being selected. All right, so we'll talk about different ways we can do that. So first, one of the most commonly used one is called stratified sampling method. So here what we do is we break down the population into different groups, called strata, and sample from each group. So for example, I can think of different ethnicity as a strata. So I don't want to only pick one particular ethnicity. I want to make sure it represents all the different races. I can have different age group as a strata. So I want to make sure that young people are represented, old people are represented, and all that stuff. So we break down population into different groups, and we want to make sure that we sample from each group so that every group is represented. The next is systematic method. Oh, actually, I'm going to talk about cluster sampling first. It's kind of similar to stratified. There's a subtle difference. So for cluster sampling, what we do is we break up, kind of same thing. We break down the population into different groups. So that part is the same. We're going to call it cluster now. We select sample clusters. So not every cluster will be selected. Then we survey everyone. In those clusters. Right? So not every group gets sampled. We break population to different groups, and then we take sample groups or clusters. But then once we decide that, we survey every single person in that group or cluster. It's called cluster sampling. So it's kind of similar to stratified, but there's a subtle difference. The next method I want to talk about is systematic sampling. That one, what we do is if we pick a first person, we pick a first person at random. then what we do is we pick every nth person. Then we pick every nth person. So, for example, I can stand in front of library, pick one person at random, survey this person, and then after that, what can I do is I can ask every 20th person that enters the library, survey this person, or every 10th person, or whatever, until I get however many I want. So that's an example of a systematic sampling. Number 4, convenient sampling. This is not really a good random sample per se, but this is something that is convenient, so we can do kind of quick. So this is not a random sample. So like if you're to do any scientific research, this is not a sampling you want. So for example, I can ask you guys, hey, raise your hand if you got tested for COVID-19 and you're positive. There was no strategy, there's no selection process. I just picked you guys as a sample because you was around. So that was an example of a convenient sampling. Okay, so we're gonna pause now. I'm gonna have you guys work on number 6 and number 7. All right, now we're gonna talk about number 8 and number 9. We're not gonna spend too much time here. I just wanna mention that there are a few different types of errors you can get. Sampling error, basically this is like either you have a bad sample or your sample is not large enough. Maybe you would just survey 2 people. In later chapter we'll talk about like exactly how many people do you have to survey to have like a good study. So we'll go in more detail about how many people you need to survey and all this stuff. But generally, if your sample is too small, that's not a good sample. You can also have a non-sampling error. So maybe your sample was good, but maybe the machine that measures the detection of the virus was not a good machine, so it just gives you false result. So maybe it's like a bad device to test for your, or maybe somebody forget to record the result. Forgot to record the result. These are examples of a non-sampling error. We are talking about all this because we want to minimize sampling bias. Sampling bias means a particular group is more likely to be selected than others. Then, as we talked about before, we want to make sure that everyone is equally represented because we're using a sample to represent a population. So if there's a sampling bias, you're going to have a misrepresentation of the population. Okay, so now I'm going to have a pause and finish the rest of the worksheet.